take a look today at the screwdriver. So with the start file here, you notice that we have a shape that mirrors what's in the tutorial. I've also added in the dimensions here. So these are all ostensibly in millimeters. Now you can see it's broken up into layers right now. We've got our construction curves. This layer is locked. And remember, when you've got a locked layer, that means you cannot select it. You can't do anything to any of the objects on that layer because that's protected. However, you can still use them as references for endpoints, midpoints, and so on. I've also got the dimensions layer here, and if that gets distracting, which it probably will be, we'll just turn that off. So right now my dimensions layer is locked and invisible. So the way this is going to work is we're going to use these construction lines to help us draw curves. And the curves we're going to use are what are called the control point curves. So a control point curve works basically like this. You plot a point, and then the next point. Now that looks like it drew a line, but notice that the next point is making a curve. And if I leave it there, you can see there is the curve that I drew. And this is a B-spline curve, or NURBS curve, as is known in the nomenclature. What's basically happening here is this. This is the start point of my curve. This is the end point. Those are fixed in space. My line is attached to them. This is a control point, and what it does is it changes the curvature of my line. Think about it as these 3 points are in a mathematical formula, kind of like the coefficients in a quadratic equation, if you've ever done that kind of math. And they are defining what the shape of the curve is. A little more complicated than that, but we don't need to get into the math. That's all in the software. Anyways, so a few things about control point curves and the way to work with them. They're very, very nice to work with. They're a little different from the Bezier curves if you've ever done any vector graphics like Illustrator. So the way we work with this is this. We start off with the control point curve. I'm going to snap to the end point right now. Now notice, just before we continue on, make sure you've got your end point and near point snaps turned on. So just down here, that's important. We're going to need those. I'm going to start at the end point. Now what I'd like to do is I'd like my curve to be parallel to this line right here. So in order to do that, I'm going to click on another point on the line, and you can see I'm snapping to the near point right here. And now wherever I go out, this end right here will always be parallel, or tangent is the term, to my construction lines, just by putting that second point in right there. Now, how much is actually tangent? It depends on my third point, but if you ever want a curve, like I said, and you'll see in a bit when we do the surface construction why that's important. So the next thing is, let's make the far end curve, and we'll make this a relatively tight radius here. So I'm going to choose this point here. I'm going to choose my corner point and another point right here. And you can see that that makes a fairly tight radius curve. The closer your control points are together, the tighter the curve of your radius will be. I want to continue on down this curve, and I don't need another point for quite a while because I would like this to continue straight. So I'll just stick a point right here. And now I'm going to have this come in. Now I don't need to snap onto the corner point. I can actually snap a point right here. And you can see now I've got a much broader curve that carries down into there. And again, come up here, there, and you can see it's not actually following the curve itself. We're just using the construction curve as kind of a guideline. Now what I'm actually going to do is I'm going to end my curve right here. I don't think this is in the tutorial, but I'm going to do it right here because I would like this to go out at a right angle. So you'll see why in a bit. So I'm going to start off another control point curve and end up over here and this is going to be the top blade of my screwdriver. And again, I'm going to want those 2 points. So that point, and they're going to define the blade of my screwdriver. And I want this to be right here. So this line is going to be perpendicular to my axis. Now the nice thing about control points is once you've drawn that, if you're not crazy about what you've drawn, you can always go back and you can drag the control points around. So that changes the shape of the curve. You can also delete control points. Just select them, press delete, and that of course changes the shape of your curve. So I actually wanted this one. I didn't want this one to go down and then back up again. I'm actually going to delete that point right there. Kind of more closely match what was in the tutorial. I'm not looking for exact perfect replication of what I had in the tutorial, but I wouldn't mind it being fairly close. Drag that out a bit, make that blade a bit wider. Okay. So that's a good curve right there. I'm happy with that. Now, what I'd also like to do is I'm going to join these two curves together. Now, notice that I got a right angle right there. Now, I can do that with control points. I can actually go back and modify control points, and I can turn them into things that are called knots, which will allow me to do a right angle. I can also change the weight of a control point, how much influence it has on a curve. That's kind of a little bit higher end stuff. We're not going to worry about that. I'm going to join these two things together because it kind of matches in the tutorial. So select those two lines. I'm going to hit Control J, and now I've got one continuous curve. So that is the outline for my screwdriver. Okay, so once I've drawn my curves, I'm going to jump down here to my surfaces layer. And again, this is kind of important because it's nice to keep everything separated on different layers so you don't get mixed up things. And to make my surface, I'm going to select my curve. Actually, I'll do this from the command. I'll go to Surface, Revolve, select Curves to Revolve. I'm going to pick this curve right here, press Enter, done. Start of revolve axis, I'm going to pick this point right here, which is an end point. And that's right on my axis. And this point right here, which is another endpoint. So this is my revolve axis. Press Enter. And now I'm in the revolve mode. It's asking me what is the start angle. Now I would like to go from 0 to 360, so I don't need to have to enter in the start angle and the end angle. I can just go up to this parameter right here and say it goes full circle. Okay, so obviously something happened. Well, here again, I'm in the top viewport, so I'm only seeing an orthographic projection of my object. So I'm going to double click up here, switch over to perspective, and there is my screwdriver. And you can see it did a nice revolve all the way around. Now, a couple of important things. First of all, this is why I wanted my start and end point to be right on the axis here, because that way when it revolves there won't be a hole in it. So this is actually completely sealed, and I can actually see that by selecting my screwdriver surface that I drew, going up here to my properties, and what I want to see is I want to see this closed solid poly surface. That means there's no holes in it. It's another way we can refer to it as watertight. So if it were full of water, no water would leak out. It's a solid, so it's acting like a solid, and it's a poly surface. It's made up of multiple surfaces that are all kind of stitched together. Now, if you didn't do what I did and you made a continuous line, you'd get a closed solid surface. I have a poly surface because I have that sharp right angle in there. Again, same thing on the other end. There's not going to be a hole in there. So that's important. All right, so the next thing we want to do, we're going to switch back to the top view. And we're going to use the wire cut, which is a really neat little tool here. So to do the wire cut, I'm going to create a cutting line. Actually, I'll switch back to my curves layer. And I'll go to curve, line, single line. I'm going to do a cutting line. So something like this. All right. And so my line, I want to make sure this goes completely through my surface. So the start point of my line, the end point of my line are completely through my surface. And I will go to Solid, Solid Edit Tools, Wire Cut. Okay, so the command, first of all, select the cutting curve. That's my cutting curve. Select Object to cut. I want to cut this. Press Enter when done. All right. Now, I have a bunch of different parameters. How do I want to cut it? Do I want to cut normal to the curve? That means it's going to go cut this way or this way. Do I want to delete the input? Do I want to keep both parts of these? Keep all? So I have a whole bunch of different options here. So what do I want? Let's see. Enter depth point. Okay, press Enter. All right. So what that shows me is that I now have cut right through, and you can see it deleted that surface. If it didn't delete the surface, this is why it wouldn't have deleted the surface. So keep all equals no. What that means is don't keep this, just delete it because I don't want it. Next time I'll switch that to yes, and I'll show you what happens. So let's just see what effect that had. We'll go back to our solid, rotate around. So you can see what it did was that it was like that wire just sliced right through my solid surface. And here's the more important part, left a surface behind. There are other techniques we could use to cut that, but they would not leave a surface behind. They leave a great big gaping hole in there. And that could be a problem later on, depending on what you're building. I'm going to take my curve here and I'm going to mirror it across my axis. So I can just use my endpoints because they define my axis. I could have also chosen the axis that I wanted to mirror it off of. So there's my wire cut again. And I'm going to right click up here because here's the list of previously used commands. I'm going to do another wire cut. Select my curve, select my object to cut, press Enter. Let's try keep all, yes, okay. And press Enter to cut all the way through. All right, so now you can see it actually kept that little section there. I'll separate that out so you can see there it is right there. So you can either keep it, just depends on what you want to do. I don't need this. Oh, there we go. All right, there is my screwdriver. Now, for the last little bit, what I'm going to do is I'm going to switch to this layer. I'm going to deviate from the tutorial a little bit because I like this. This looks better to me if I do this. It's a similar but different. So what I'm going to do here is I'm going to start with a cylinder. And I'm going to turn on my, let's snap to quad is a good, okay. Not going to snap to quad. Doesn't seem to want to snap to anything up there. I don't seem to have any reference points along that line on that surface. Okay, well, I'll tell you what then. Let's turn on my grid snap. Grid snap works. I'm going to draw myself a cylinder. And this is going to be a kind of a sacrificial part right here. I'm going to use this to cut an object through. That's why I was on the right-hand side. Okay. So I'm going to draw my cylinder here, and you can see it extending out. Now, what I'd actually like to do, I would like it to go on both directions. So I'm going to choose both sides, drag that out. There's my cylinder. So what this is going to do, this is going to be used for cutting the flutes in the handle. And maybe I'll just turn on the gumball here. If you've never used the gumball, it's a very useful, very intuitive tool to move things around. So use there we go. So I just moved it up a little bit so it fits in there. So that looks good. What I'm going to do now is on my right viewport here, I am going to do what's called a polar array. And that just means make multiple copies around a center point. So select that object. Okay. Here is the center of my array, which coincides with the center axis. Number of items, let's say about 10. And again, how far around do you want to go? I'm just going to go 360 degrees, so I'm just going to press enter. And there we go. Okay, so there's 10 of my cylinders arranged in a row. Now, still waiting for me to press enter to accept it. So I'm going to press enter. Yep, that looks good. Now here's another reason why I dragged them out so far. I didn't need to. They only need to be the parts intersecting, but you'll see why when I do a selection. So what I want to do now, I'm going to do solid difference, select poly surface, subtract from, select my screwdriver, press enter. Okay, now what to subtract with? Well, fortunately, I've got these objects overhanging over here, so I can just drag a window to select them all and press enter. And there we go. There's my nice fluted handle. And I think this looks more realistic than the way they do it in the tutorial. So you can see this is a combination of two different kind of construction techniques. There is additive. So additive is when I drew the lines and I made the revolve. That created the solid. And then subtractive. Subtractive is where I'm cutting out chunks of it using various reference lines and reference solids. So this is what you want to think about whenever you're making a model, is what parts can you create from a solid or for adding, and what parts can you create from subtracting. So in the next part, we'll take a look at rendering this.